is the Doppler effect? Well, have you ever noticed that when a fire truck drives by you with its sirens blaring, the sirens seem to be a high pitch when it's coming towards you, but a low pitch when it's driving away from you? That's the Doppler effect. But it doesn't just work on fire trucks. It works when any source of the sound wave is moving relative to an observer. Take this car, for example. When both the car and the observer are still, the car produces steady sound waves that remain the same distance apart, keeping the pitch constant. But when the car starts to move and the observer stays still, that's when the Doppler effect kicks in. To the observer, the pitch of the car's horn is changing. As you can see, the sound waves in front of the car seem to get closer together, while the ones behind it seem to spread out. To the observer, the car is essentially chasing the sound waves in front of it, causing the sound waves to get closer together, creating a higher frequency and therefore a higher pitch. The opposite is happening to the sound waves behind the car. The car is moving further away from the direction its last sound wave is going, causing them to be more spread out, have a lower frequency, and a lower pitch. So, assuming that the car stopped and started at the edges of the screen, an observer in the middle of the screen would hear a high pitch as the car came towards them and a low pitch as the car passed. An observer all the way on the left of the screen would only hear a low pitch, since it's only encountering the lower frequency wavelength. And an observer all the way on the right of the screen would only hear a high pitch, since it's only encountering the high frequency wavelengths. The weird thing is, the driver wouldn't hear a change in pitch at all, since the Doppler effect only works when a wave-producing object is moving relative to an observer. Since the driver and the car are moving at the same speed, they have no relative speed between them. The actual frequency of the waves the car is producing is not changing. And since there is no relative movement between the car and the driver, the frequency the driver hears is the actual frequency. The cool thing about the Doppler effect is that it doesn't just work with sound, it works with all waves, including light. When the frequency of light appears higher, the wavelength becomes shorter, creating a blue shift. But when the frequency becomes lower, the wavelength becomes longer, creating a red shift. So an object approaching you would seem blue shifted, but an object moving away from you would seem red shifted. This change is too subtle to see in cars or any other everyday object in motion, but it is very important. Astronomers use the Doppler effect to determine whether light-emitting bodies in space, like stars or galaxies, are moving towards or away from Earth, and at what velocity they are moving. Astronomers have looked at many galaxies using the Doppler effect and determined that most of them have been redshift, meaning that they're moving further away from Earth. This provides evidence that the universe is expanding and supports the Big Bang theory. From space to sirens, the Doppler effect can be seen or heard almost anywhere.